find the sample size. Okay, it says find the p-value by calculating the probability of getting a t-statistic this large or larger in the direction of the alternative hypothesis. Okay, we do this on Desmos. You just write Desmos. Okay, and when we do that on Desmos, and we click on the t-test, we go to significance test drop down, and based on what our alternative hypothesis is, we pick the tail that matches. So for example, on the first one, mu1 greater than mu2, that would be what tail? The right. What about that last one, mu1 less than mu2? Left. And then what about the middle one, not equal to? Good, both. Okay. It says use the t-distribution with degrees of freedom approximated by the smaller of the sample sizes. No, we don't do that. Cross that out. Okay. Remember, that is called a conservative method. The reason we do not do that is because when we use that conservative method, it makes our confidence intervals too what? Wide, too large, and it makes our p-value also too large. Okay, so we use technology to find degrees of freedom, and even though we include that in our communication part, we don't find it until we do the calculation part. And this will always be under what tab? Confidence intervals or significant test? Significance test. So this is on Desmos under significance tests. And remember, how Desmos calculates this is by using that long formula we saw yesterday. Okay, so you could actually calculate it yourself and get the same number that Desmos is getting, but that's too much work. Don't do that. Okay, any questions so far? Okay, this is a very short notes. Okay, on to our example. Okay, for our example, we're doing a 2-sample t-test for a difference in means. It says, does increasing the amount of calcium in our diet reduce blood pressure? Examination of a large sample of people revealed a relationship between calcium intake and blood pressure, and the relationship was strongest for black men. Because observational studies do not allow for us to draw a cause and effect conclusion, a randomized experiment was designed. So is this going to be a sample or an experiment? An experiment. The subjects were 21 healthy black men who volunteered to take part in a double-blind experiment. What does that mean, double-blind? Good. The subjects and the researcher does not know what treatment they got. They were randomly assigned into 2 groups. 10 men received a calcium supplement, while the control group of 11 men received a placebo pill that looked identical. The response variable is the decrease in systolic blood pressure for a subject after 12 weeks in millimeters of mercury. An increase appears as a negative number. Here is the data. So now that we have this table, what's the first thing you should do on Desmos? Good, create 2 lists. And since we're talking about calcium and placebo, what would be a good idea to label out these lists? C and P. C and P. So go ahead and type these lists into Desmos, because we're going to need these lists to find all our information to write in the communication box. Okay, so everyone should have Desmos open. If you don't, look off of Bestie. Okay, so while you're typing in those lists, I'm just going to continue reading the problem. It says, does the data provide convincing evidence that a calcium supplement reduces blood pressure more than a placebo? It says, carry out an appropriate test to support your answer, then interpret the p-value you got in context of the experiment. Okay, so notice it just says provide convincing evidence and then carry out an appropriate test. Notice it doesn't mention anything about a confidence interval, and it doesn't mention anything about a significance level. So how do we know which test we are going to be doing? There's one word in there that tells us, besides the fact that this is a significant test notes, right? There's one word. The p-value right here. Okay, when is the only time we find p-value? On a significance test. Okay, so I'm going to go ahead and draw my boxes so I can separate my communication, conditions, calculate, and conclusion. Okay, so for communication, our first thing is to always define our parameter. Okay, so since we're doing a mean, so a test for mean, our parameter is mu. And since we have two of them, instead of them labeling mu1 and mu2, let's go ahead and call it mu c and mu p, right? Mu c for the calcium supplement and mu p for the placebo. So we could say that these parameters is describing the mean difference in systolic, it's a word, blood pressure for the calcium group. And then the same thing, but then for the placebo group. Okay. Since this is a significance test, that means we need to write our hypotheses. So our null hypothesis is that there is no difference, which means that mu c is equal to mu p. Remember, you can write this as mu c minus mu p equals 0. It's the same thing. Our alternative hypothesis, if we go back to the part of the question that I highlighted right here, it says the calcium supplement reduces blood pressure more than a placebo. That tells us a directional, which means our alternative is going to be mu c greater than mu p. Okay. Remember, if we do not see a directional, then we put do not equals. Okay, since we're doing a significance test, we also need to know what alpha is. However, does it mention a significance level? No, it doesn't. So if we are not given a significance level, then we always assume it's what? Say that again. 5. Well, 0.05, right? 5%, 0.05. Okay, again, if it's not given, that is the assumption that we make. Okay, then we need our means, so x bar p and x bar c. Okay, how do we find those? On Desmos. So go ahead and go on Desmos and do the mean function for c and then the mean function for p. Okay, what else do we need to do on Desmos? Standard deviation. So go ahead and calculate the standard deviation for both. So again, we use mean. And this one we use standard deviation. Okay, and for standard deviation, you can just round to 2 decimal points. Okay, then we need to label our sample size. So our sample size for C is 10. Our sample size for P is 11. And then we're missing one piece of information that we can't find till later. Degrees of freedom. So I'm going to label it so I don't forget to come back. Okay, and then I'll fill that in once I get to calculate. Okay, my next part is to do my conditions. So remember, there's 3 conditions. Am I going to do all 3 conditions? Nope. Which one am I skipping? Independence. Why am I skipping independence? Because an experiment, we do not do the 10% condition for an experiment. So on conditions, I have my random condition. And since an experiment, I'm looking for random assignment. And notice in the problem, it says randomly assigned to 2 treatments. Right, the first treatment is the calcium supplement. The other one is the placebo. And then for normal, we have to see if both sample sizes are greater than or equal to 30. Are they? No, so we say both NC and NP for the sample size of each are less than 30, so we graph. Okay, so you need to create a histogram for both of these samples. Okay, remember when you create these histograms, you need to establish the bin width. And remember, the bin width is what? Range divided by the square root of n. And our goal is to have how many bins? 5 or 6? Okay, so I'm going to go to Desmos and I'm going to do this along with you. Okay, again, remember you go to functions, go down to histogram, and then make sure that my histogram has what bin alignment? Left. Then I establish my bin width by doing my maximum minus my minimum divided by the square root of n. Okay, and then I try all these different ones. So 7 gave me 4, so 7's not going to work. I go 1 up. 8 gave me 4 as well. So if you end up with 4 and both of your numbers didn't work, try 1 more down and 1 more up. So we would try 6 and then 9. So 6 gave me 5. That works. And let me compare it with 9. 9 still gave me 4. So I'm going to choose 6 as my bin width for the calcium histogram. Again, when I did my bin width, I got 7.2, which means I should have chose 7 and 8. Neither of those worked. So then I went 1 down to 6 and then 1 up to 9. Okay, and 6 was the one that fit. Okay, same with the other one. Okay, for this one I got 6.9, so I'm going to try again 6, which gave me 4. I'm going to try 7, again gave me 4. So let's try 5, and that one works. Okay, so as you're creating these histograms, you should notice that in your placebo histogram, what is happening? We have an outlier. Okay, does that mean we stopped the problem? No, what are we writing in our conclusion? Proceed with caution. So I'm going to go ahead and draw both of these histograms. Remember, it doesn't need to be perfect. Rough sketch. Just make sure that you have labels. Back and look at it one more time. 1. Okay. So there's a rough sketch of both of my histograms, and I clearly see my outlier in the placebo histogram because I made sure I left that gap there. Okay, so now I'm looking at both of them, and I'm going to mention if I see a outlier and if I see extreme skewness. So I'm going to write for the calcium graph, there is no visible outliers. Unlike the placebo graph, there is one around, and if you look on Desmos, where would you say the interval of that bin is at? Just an estimate. Anybody? So I don't have to go back.
Wait, what'd you ask?
So like where this outlier bin is, what would you say the interval of that is on Desmos? Because that's the most accurate. On Desmos, zoom into that one that's an outlier and look at the x-axis. What are those numbers? Negative 15, negative 10? Okay, around negative 15 and negative 10. So it says, okay, unlike the placebo graph, there is one around, okay. Both graphs don't show extreme skewness. Okay, so we mentioned both graphs. So we said the calcium graph didn't have any visible outliers. The placebo one did, around negative 15 and negative 10. Both graphs don't show extreme skewness. So you can choose to write this into 2 statements or combine it into one. Just make sure you label them and don't say it or they, right? Be as specific as possible. So in this case, calcium versus placebo. Okay. From here, we move on to calculate. And then for calculate, remember we name our inference. So this is a 2 sample. Okay, because we have 2 rows of data here, calcium versus placebo. T-test. T because this is a t-distribution and we're using an estimate of the standard deviation S. And test because it's a significant test for means. Okay. From here, this will give us T star and our p-value. Yes, it will also give us the degrees of freedom, but remember, where do we write that? Communicate. So if I go to Desmos, okay, I'm going to go to add an inference, and I'm clicking on t-test. Okay, t-test. I'm going to put in both my sample data lists. So C for the calcium, click on the plus sign and do P for the placebo. Then I'm going to hit create tests. I'm going to click the drop down for significance test. And I'm going to make sure to put what number for the null hypothesis? 0, because no difference is the same as saying 0. And then which tail am I going to look at? The right, because my alternative hypothesis was greater than. So if I zoom in here, notice that I find my p-value of 0.064. I find my t-star value of 1.604, and that's why the doors are always locked, right? Crazy people. Degrees of freedom is 15.59. Okay, so I'm going to write those there. So T-star 1.604, p-value 0.064, and degrees of freedom 15.59.
So that was not me, but God bless you guys.
Okay.
Yeah. My friend. And I was like, wow, I'm gonna give this a couple seconds and this is really embarrassing.
Okay, so now we're on to conclusion. Okay, and since this is a significance test, remember we're taking our p-value and comparing it to alpha. So looking at our p-value, we would say since our p-value equal to 0.064 is what? Less than alpha, greater than alpha, okay, is greater than alpha equal to 0.05, we fail to reject the null hypothesis, which means we have convincing or we do not have convincing evidence. We do not. So we do not have convincing evidence that calcium supplements reduce blood pressure more than the placebo. Okay. What do we need to write in big, bold writing at the end of this? Proceed with caution. So we say proceed with caution since the placebo graph didn't meet the normality condition due to an outlier. Remember, we add that caution statement either in the beginning or the end, okay? to make sure that they take our data with a grain of salt, meaning they don't take it literally, because it could be wrong because we didn't meet that normality condition, and we write it there so we can't get what? Sued, so we can't get sued, right? Not gonna get in trouble, but so you don't get sued, right? That's the same reason why on the hand sanitizer jugs it says it kills 99.9% of viruses. Okay, if they said it killed 100% of viruses and then you still got sick while using hand sanitizer, you could sue. Okay, and the very last question here told us to interpret the p-value in context. So remember, the p-value is the probability that something happens. So if calcium has no effects on blood pressure, the probability we get a difference is about 6.4%, because our p-value was 0.064. That is a percent is 6.4. So the probability we see a difference if calcium has no effect is about 6.4%. Any questions on the FRQ?
So that was just answering that last part, right?
Yeah, just because it said, then interpret the p-value. So we had to do both. Okay, remember this is all just part of your conclusion. Okay. Yes. Okay, one last thing. You should have a blank page or a couple blank pages after your notes. Okay, we are going to draw a flow chart to help you decide which inference to use. Okay, remember we learned all these different inferences. Here's the flow chart. Okay, I'm going to walk you through it. So, remember when we talked about inference statement, we talked about proportions and means. So, if your inference had a parameter of a proportion, your next deciding factor is to see if it was a 1 or 2 sample. Okay, no matter which one it is, you're going to be using a t-test for proportions on Desmos. If it's a 1 sample, you're going to put in your data for 1 sample. If it's a 2 sample, you'll put in your data for 2 samples. And then from there, you need to choose if you're using a confidence interval or a significance test, which means when you're naming this inference, don't name it t-test unless it's a significant test. I only highlighted t-test on here because that is how Desmos has it written. So for example, if you had a proportion of 1 sample for confidence intervals, you would say that this is a 1 sample t-interval for proportions. Okay. Now for means, let's say your inference is a mean. Okay, the first thing you're going to ask yourself is if it is a 1 sample or a 2 sample. Okay, if it's a 1 sample, okay, that's straightforward. You go straight to t-test on Desmos, and then you choose if it's a confidence interval or a significance test. Okay, so for example, let's say it's a significance test. So you would say this is a 1 sample t-test for means. Okay, inference for means of 2 samples is where it gets a little complicated, because we can have a regular 2 sample, okay, like we did today, or we could have a matched pair 2 sample, and that's where we did the IQ test, where you guys had to take your 2 lists and do the difference of the 2 lists. Okay, so if it's a regular 2 sample, you go to t-test, you choose confidence interval or significance test. Okay. If it is a matched pair, okay, and it will say it in the problem, it will say a matched pair design. Then you choose a t-test, and instead of using 2 lists, you're only using your difference list. And then deciding if it's a confidence interval or a significance test. Okay, so let's say it was going to be a confidence interval. Okay, so you would say that this is a 2-sample matched paired T interval of means for difference, or for difference of means. Okay, so you'd have to label every single part.